Here's some practice on writing formulas for ionic compounds and naming those ionic compounds. And so I would suggest that you've got paper, pencil, a list of your polyatomic ions, and that you are ready to get busy writing these formulas. All right, so let me show you our first two elements that you're going to be writing the formula for: strontium and selenium. Of course, strontium, a group 2 alkaline earth metal. Selenium, a non-metal, and as they come together, they make an ionic compound. So what would be the formula and the name? Great time to pause the video. All right, so how did you do? First, of course, you had to figure out the charge for strontium, 2 plus, selenium, 2 minus. And then, of course, you're going to need to cross those charges using that cross rule like we did in class. And as you're doing that, you should come up with something like this for the formula. And then you'll realize as you're looking at that formula, wow, all I need to do is get these two to equal 0. 2 plus and 2 minus already equal 0. So of course we don't need 2 strontiums and 2 selenides or seleniums to get there. And so we would simplify that formula to be this, SRSE. And the name for this compound? Strontium selenide. Let's try another one. Calcium and hydrogen. Sometimes hydrogen can act like a non-metal and have a charge of -1. So now with that little bit of knowledge, what would be the formula and the name for this compound? All right, so as I determine my charges of my ions, of course, I'm going to use my cross rule as always to figure out how many of each I'm going to need. And I'm going to get CaH2, which of course is calcium hydride. All right, our third one, lithium and nitrogen. Go ahead and see what you can do with those. So hopefully you figured out that we've got a 1 plus and a 3 minus. So as you cross those, you're coming up with something like this. And the name, of course, is lithium nitride. Here's the fourth and final one of these for you, sulfur and aluminum. All right, a little tricky thing I did there to you. You'll notice that I put the sulfur first and not the aluminum. When you're writing these formulas, these compounds, you always have to put the metal first. So I'll need to switch that around as I figure out the charges of my ions. And then I come up with my formula of Al2S3 and the name aluminum sulfide. All right, so at this time, this is really practice. Now that I've refreshed your memory on how to do these, we're going to go ahead and see what you can do. Whatever you've got, bring it with you to class, and we will check how you're doing. All right, so here's a periodic table. In case you don't have one handy, you may want to snap a picture of it. Here's a list of polyatomic ions. This is probably not exhaustive of polyatomic ions. Like I don't see borate on there, and every now and then we'll come up with borate. But having a picture on your phone would probably help you as you're working on these formulas. All right, so what would be the name for this one? How about this one? The third one. The fourth one. Now here's where you'll have to look at your list of polyatomic ions. And again, And again. As you're taking a look at that gallium, you may want to be thinking about transition metals and what we have to do with them. And the 9th one for you, number 10, the name for this compound. Number 11, you'll notice that phosphate here is not in parentheses. We only need one phosphate. All right, now how can you do formulas to names? So, well, that's how you did formulas to names. How about names to formulas? The formula for aluminum fluoride. How about calcium nitrate? And so again, as we're looking at this, the binary compounds with transition metals, just so you know, for our purposes, sometimes if you're using the computer, they will give you special endings, like instead of saying copper, they'll say cupric, for the endings of the transition metals to tell what their charges are. We won't be using that method. So if you Google something and use some artificial intelligence to tell you the name of the formula, that would be incorrect.